Hello everyone, this is Team 9, Sea Pickles, doing our presentation on Euler circuits and paths. Done by Alejandra, Rayhan, Aaron, Jocelyn, Sarah, and Mateo.
So what is and how to identify an Euler circuit? An Euler circuit is a path that visits each edge of a graph exactly once and starts and ends at the same vertex. And you know that a graph has an Euler circuit if every vertex has an even degree. So in this example, you would start at 0, then you'd go to 1, then you'd go to 2, then back to 0, then go to 4, then go to 3, finally you're back at 0.
So for these examples, we can first take a look at the example on the left, where we're going to start at vertex A, then we go to C, then E, then B, then D, and we end at A. On the example on the right, we can start off at B, then D, then F, then G, then H, then E, then C, then B, then A, then D, then G, then E, and we end at B. Remember, it has to be a closed path, and every vertex has an even degree. If it has an odd degree, then it is not a circuit.
What is and how to identify an Euler path? An Euler path in a graph is a path that visits every edge exactly once, but does not necessarily start and end at the same vertex. If a graph has exactly 0 or 2 vertices with an odd degree, it is an Euler path. If there are more than 2 vertices with an odd degree, an Euler path does not exist. If you look at this example and you disregard the 2 arrows crossing in the center, you can go from point 1 up to 2, then 3, back down to 4, and ending at 5, and this would be an Euler path because vertices 2 and 4 are the only 2 vertices with an odd degree. Whereas if you start to look at this example with both arrows in the center, vertices 1 and 5 would also have an odd degree, which would not be an Euler path.
Now let's look at some examples. On this slide we have 2 examples. We need to remember that a Euler path is a graph that visits every edge exactly once, but it doesn't have to end where it started. Looking at this first graph on the left, we can trace a path that visits every edge once. For example, starting at number 1, then we go to 3, and then we go to 2, and so on. The key is that the graph has exactly 2 vertices with an odd degree, which makes a Euler path possible. On this second graph on the right, we have another example. Here the path starts at vertex C and ends at vertex E, passing through every edge only once. It goes from C to A to B to C again, then to E, and then it ends at E. These examples can help us visualize how a Euler path works.
After learning everything about Euler paths and circuits, here are a few things to help you remember the difference. An Euler path will start and end at different vertices. There are 0 or 2 odd degree vertexes allowed, and it is not a closed loop. For an Euler circuit, it will start and end at the same vertex. It requires all even degrees, and it will always be a closed loop.
We hope that our presentation has made it easier for you to identify Euler paths and circuits. Thank you for watching.